Hey guys, so today I'm going to be going over just a workflow for an application load balancer to point to an ECS container in the backend. So basically, we're just going to go from what the start to finish workflow is like. I feel like that's the easiest way to understand it. So basically, you have your application load balancer is the front gatekeeper to your backend instances. And the way that this works is you have your domain record and you point your domain record to the DNS name of the application load balancer. And once this gets hit, it will go to the listeners, depending on the port that you're attempting to access on. So if we go ahead and we look at the listeners, we can see here that we have a HTTP port 80 listener and then an HTTPS 443 listener. Just keep in mind that your 443 listener, if you want it to have an SSL certificate, you're going to need to add one using AWS Certificate Manager. If you're going to be doing host name based routing, so if you're going to have different subdomains and you want them all to have an SSL certificate once they're going through that load balancer, you're going to want to use something called a wildcard certificate. And basically all this is you have just this asterisk right here. And anytime you add any additional subdomains and point them to that application load balancer, they're going to go through this certificate and they're going to have the little lock bar, which is basically means that you're running over HTTPS using a validated certificate. So the reason you have a listener for port 80 is because sometimes when you navigate to a URL, you know your users aren't going to really be typing HTTPS // and then the name of the URL. They're just going to type the domain name and then just try to access via that. So what you want to do is you want to actually redirect the users to HTTPS. And the way that this works is with your listener, you just have one rule set up and you basically just say any request that comes in. So if it's not otherwise routed, let's say we have an additional rule above it. That's not the case in this instance. We're just going to redirect to HTTPS, passing in that host that was passed in, going over 443, and then also just adding on any additional information that was passed on in the header as well as the path. And we're going to be using the status code of 301, which stands for permanently removed. You have like two options with this when you're doing a redirect like this. You can do 301 or 302. 302 is temporary, but that's not the case for this because we want them to always go over 443. So we're just going to go ahead and go with 301. And here you have your HTTPS listener rules. So if you go ahead and you click right here, you'll be able to edit the rules for once your listener is hit. So just remember that the application load balancer is just the gatekeeper to the backend instances, and you actually have to tell it where to go. So if you have multiple subdomains, you would just add additional rules and you would just use the host header option. So you would just add a rule and then you would use the host header condition and specify the subdomain name that you want to use to route. And all you would have would be multiple target groups for each container that you want to point to, and you would just forward it to that container or to that target group. So you can have a catch-all at the end. I only have one target group here. That's why these two are the same. But there are instances where you have multiple, and you would just put your host name or your subdomain and then point it to a target group, and then you would have another one with another subdomain and point it to a different target group. So as you can see here, I have port 80. That's because the communication between the user's browser and the application load balancer is what determines the SSL certificate status. The communications between the load balancer and the backend instances is not using HTTPS. You can use HTTPS, and it's recommended, especially if you have sensitive information or if you're trying to maintain compliance with HIPAA. Basically, you would just have to add an additional certificate between those two in that communication. So here you have the target group that it is pointing to. And then you see here I have one registered target. If you're running into any issues with you're hitting your application load balancer properly, but you're not getting to that backend instance, be sure that you have the port configuration set up correctly on the actual container, and you are using the correct port for the target group as well. So this is a demo cluster that I have set up here. Basically, the way that this works is you have a list of tasks and a list of services. And the way that it works is your task is your running container. That's your one-off container. If you just run an individual task and then you shut it down later, it will just shut down. But if you have a service and you create a service, the service actually runs the tasks. So if you were to have a task fail or you were to shut it down, the service will actually restart the task and spin it right back up. So this can happen if you have an issue with an error causing your task to fail off. The service will actually provision a new task depending on the configuration that you have for desired tasks. I just have one here because this is just for a demo. So a little bit of a deeper look into the the service configuration. You can see here that I have this single container running on, and I say basically to the service, keep this container up and running. I only want one running constantly, and run it off of port 80. So when the target group gets hit, have the target group communicate with this container over port 80. Here's a look at the task. Basically, like the most important part here is that you want to see that the task is actually running. Once you start a task, it's going to show up as pending, and then it's going to show up as provisioning, and then pending, and then running. So once you see it running here for a little bit and you go back to your target group and you see that it's unhealthy, or whether or not it's healthy or unhealthy, that's how you determine whether or not you have it all configured correctly. So this is an ECR repository, and this is what you use for your task definitions. This is basically just an image. This is where you hold your container images. So what you would do is you would either have, if you're going to be doing this in more of a production environment, you would have, GitHub or something building the container and publishing your container to this private repository, and then you would have your task definition be updating off of this, which would then later update the service, and it would basically update the running container to the latest image that you have here. So you can have multiple repositories here. It's generally probably a good idea, especially if you have a production environment that you're running a business on or something. You want to have a difference between your staging and your production. And what you would do is you would just have separate repositories, and then on GitHub you would have your separate branches, and when you push to your staging branch, you would have GitHub build the staging or the image and then push to the staging repository, and then you would have your task definition read off of that, and you would have separate task definitions as well. So we're going to go full circle here, and I've already done it, but we're just going to navigate to the hello world.cavinex.name, and it shows that we have the hello world. And I changed from the previous tutorial on how to build Docker images, or to how to Dockerize PHP applications. I changed it to hello from ECS container behind application load balancer. All right, thanks for listening. Feel free to reach out if you have any questions. I'll leave my contact information in the description as well. Have a good one.